Welcome back, students. Let's take up the last problem for today. This problem number is 4.6. This is also based on radial line development method. You can come over to the sheet. Let me read out the problem for you. The problem is like this. The problem number is 4.6. The reference number is 17 from the VTU primer. The drawing number is 16. The inside of a hopper of a flour mill. You know what is a hopper? In a flour mill, there will be a funnel like thing where the grains are poured. Okay, the raw material is poured. That is what is called hopper. So the inside of hopper of a flour mill is to be lined with a thin sheet. Okay, it has to be lined with a metal sheet. That is the requirement. The top and bottom of the hopper are regular pentagons. Okay, with each side equal to 30 mm and 22.5 mm respectively. That means the top pentagon has 30 mm side, whereas the bottom pentagon has 22.5 mm sides. The height of the hopper is 30 mm. This is nothing but the frustum of a pyramid. We have done one problem on frustum of square pyramid. This is in fact frustum of a pentagonal pyramid. The top pentagon is of 30 mm side and the bottom pentagon is of 22.5 mm side with the height as 30 mm. So draw the shape of the sheet to which it has to be cut so as to fit into the hopper. So the requirement is that you need to draw the development of the lateral surface of the frustum of pentagonal pyramid here. Okay, that's it. So we'll start by drawing two concentric pentagons in the top view and then draw the front view. Okay, so let me draw a short XY line here on the right side. Here you should plan it in such a way that the front view occupies more space, because you will find the reason later. So I am leaving more space at the top. I am drawing XY line somewhere here, a short XY line. So here I have to draw two concentric pentagons. The smaller one is of 22.5 mm side and the bigger one is of 30 mm side. I am starting with one vertical edge. This is of 22.5. Okay, let me complete the pentagon. Yes. Now concentric with this, you have to draw another pentagon of 30 mm side outside. For that, I would suggest this method. You know how to draw the perpendicular bisectors. Let us say this is the perpendicular bisector for this edge. Just extend it out. Similarly, all the perpendicular bisectors, you don't have to draw the inside portion, just extend it out. Similarly, this one, this, and then this one. After extending these outs, now you can draw the outside pentagon. This should have 30 mm side. So adjust your scale parallel to this line and then just move out like this. Just coincide your scale with this, just move out. Once you get the distance between these two lines 30 mm, stop there and draw the line. Okay, this side has to come as 30 mm. That's how you have to adjust. Once you get this, you can go on drawing parallel lines to the remaining edges so that you get the outside pentagon. So these are two concentric pentagons. Now you find the center. Both will have the same center because they are concentric. So let us call this as O1. Let us say this is A, B, C, D and E. Now we are going to name these as section points 1, 2, 3, 4 and 5. Okay, so that completes the top view. Let me dimension the edges. This should be 22.5 and this should be 30. Okay. Now let me draw the front view corresponding to the base A, B, C, D, E, F. So, but what is given in the problem is the upper pentagon has 30 mm side. Okay. So this I should project to the top. A, B, C, D, E. I must project to the top. You take it to the topmost position because you require some space. This is the projector for B and D. And this is for C. Take it to the topmost position and draw the base there. So this is A dash, E dash, this is B dash, D dash and then C dash. Okay. Now the height of the hopper is given 30 mm. So from the top you take a height of 30 mm. This is 30. Approximately somewhere till here. This height has to be marked as 30. So on this line you will get the points 1, 2, 3, 4, 5. Now project the points 1, 2, 3, 4, 5 onto that line. This will be the same line, center line. This is the projector for 3. So now you can name the points 1 dash, then 5 dash in brackets, okay, 2 dash, 4 dash in brackets, then 3 dash. Now here, if you look here, point 1 is connected with A, point 5 is connected with E. So here also you do the same thing, 1 with A and 5 with E. Here 2 with B and 4 with D. This line will not be vertical line. You can see here 2B is inclined. Similarly 4D also will be inclined. So there will be 2 different projectors. This is the projector for B and D, and this is for 2 and 4. Okay, so 2 is connected with B and 4 with D. This is the line. Similarly 3 with E. And this is the center. Now what is important is you need to find the vertex for the pyramid with the base A, B, C, D, E. Okay, the base is here. It is in fact inverted pyramid. Okay, so the vertex you are getting at the bottom side. So to get the vertex, what you have to do, you just have to extend these lines. Just extend them down. This is the reason why I asked you to leave more space at the bottom. Similarly extend this as well and this as well. So when you extend, if you have drawn it properly, they will all meet at the same point, which is the vertex. Okay. This you can extend up and call it as O1 dash. So this is the full pyramid with ABCDE as the base, and now you are considering this as a cutting plane. So 1, 2, 3, 4, 5 becomes the section points. Now if you look at the top view, these are the slant edges, OA, OB, OC, ODE, OE, they are all slant edges, of which only OC is parallel to XY. So O dash C dash will be true length in the front view. So you need to measure this dimension O dash to C dash, that becomes the true length of this slant edge. Let us say this dimension is some X that you have to measure with the compass. Similarly, if you consider this to be a cutting plane 1, 2, 3, 4, 5, you need to measure its distance from the vertex as well. This is the true length. So on the same true length, you will measure this length as well. This will be, let us say, Y. So now I am going to draw two arcs with the X and Y as radius. Okay. Let us say the first arc has a radius of X, and the second arc I will draw with Y as radius. Let us say this radius is Y. Okay. Let me show the radial lines. This is Y, this is X. Now you can start with one of the slant edges, OA. This is O. So this is the true length of the slant edge OA, which is X. Now the dimensions 30 mm each, the outer pentagon. So you can start drawing arcs with 30 mm dimension. This is B, C, D, E, and then A. Each is 30. Name the points A, B, C, D, E, and F. Connect them using straight lines. Because it is a pyramid, the base edges will be straight. Now you can just connect them with the vertex so that you get the slant edges. You can make all of them light. These are the slant edges. Now to get the points 1, 2, 3, 4, 5, they are already there. If you want me to name the section points, the section points are here. Point 1 you can take on OA, then 2 is on OB, 3 on OC. These are visible points. Coming to the invisible points, 4 is on OD and 5 is on OE. 4 and 5 are invisible points. Now you can mark them on the development. 1 is on OA. Where is OA? Here. This is 1, 2 on OB, 3 on OC, 4 on OD, 5 on OE, and 1 on OA. I should mark this as A. So even these you should join by straight lines. 1 to 2, 2 to 3, 3 to 4, 4 to 5, and 5 to 1. And this measurement should come to 16 mm. This is important. Especially when you do on the solid edge, that should come to 16. This of course is, it is 22.5. This is 22.5 and this is 30. This anyway, you are making it 30. So it will come 30. But this arc, if you have not drawn it properly, in other words, if Y is not taken properly, then you don't get this 22.5. Okay? So it's very important to measure this dimension properly, Y, and take this cutting plane properly at proper distance. So this is the retained portion which gives you the frustum of a pentagonal pyramid. So the sheet has to be cut in this shape so that this will exactly fit into the hopper of the floor mill. So you should name this as development. Don't forget to write development, because is it this piece or this piece to be considered as development, you must mention. Okay, though you are marking it dark, you should write that that piece is the development for the given problem. So that's it, students, for this class. When I come back with the next class, I will be solving the last two problems of development of surfaces. With that, we will be completing the syllabus. 100% syllabus will be completed when I come back in the next class with those two problems. So see you then. Have a good day.